Hi, my name is Richard Campfield. I'm the president of Ultrabond, and this is one of our educational tutorials on windshield repair. This PowerPoint presentation in particular is on adhesive properties, stresses on the windshield, and some data. And you'll see how all of this correlates, and once you understand this, you'll be able to do a better windshield repair. You'll understand what you're doing. When it works or it doesn't work, you'll understand why. Okay, so this title, this one is called Windshield Repair Tips. And again, I'm from Ultrabond. Ultrabond is a windshield repair manufacturer. We're headquartered in Colorado. We manufacture the resins and tools and primers and adhesion promoters for windshield repair. We've got waterproof resins, crack resins, stone damage resins, custom-made tools. We sell them worldwide, and we also own and operate a windshield repair and replacement business. We've had a retail repair business since 1986, and then we started doing replacements in the mid-90s. But mostly we are repair-oriented. I'm also the president of the National Windshield Repair Association, and this is March 2015. Windshield repair tips. Fundamentals of adhesion. This is a page I'm going to spend some time on, and once you understand this, you'll know what's going on with your resin and the glass and the PVB. Interaction. The atoms of the resin interacting with the atoms of the glass. This is called a chemical bond, when the atoms of one liquid interact with a solid, and then the liquid is cured into a solid, and they are bonded molecularly. Wetting, very important to understand wetting. This is the ability of a liquid to maintain contact with a solid surface, in this case glass, resulting from intermolecular interaction when the two are brought together. Okay, let's say that again. The ability of a resin to maintain contact with a solid surface, in this case it's going to be glass and PVB, resulting from intermolecular interaction when the two are brought together. Okay? There is no wetting of the PVB, and this is important to understand. Okay? Windshield repair resin is made to bond to glass, and glass is a high energy surface. Resin is low energy. When you bond something together with adhesives, you have to deal with surface energy. And when you have a high surface energy, such as glass, it's easy to have an adhesive bond to it because most adhesives are going to have low energy. Okay? Now, the problem we have is we have two substrates to bond to. We have glass and we have PVB. And this creates a problem with windshield repair. A problem if you don't know how to address it. Ultrabond has addressed this both in the cracks and in the repair of stone breaks. In fact, it was addressing this issue is why we have 20 windshield repair patents. Many of those were solving the problem of resin not staying on the PVB. Okay? So what happens when you inject resin into a crack? The resin is made up of molecules, and these molecules are going to interact with the glass, atoms of the glass, okay? Because again, it's a low surface energy, and the glass is high energy. Okay, so when it is more attracted to one surface than the other surface, there's going to be a problem because, see, PVB is also a low energy surface like resin. They're so close together that there is no intermolecular interaction between the resin and the PVB. So you have to bond to the PVB or you're going to have refraction. Okay? And I'll address how do you bond to the PVB, because you have to. You bond to the glass so that the crack doesn't spread further and you restore the structural integrity. But if you don't bond to the PVB, your repair is going to look like it's not repaired because there's going to be a separation from the resin and the PVB, which will refract, it will glare, and that is unacceptable. It would fail the standard, the repair of laminated autoglass standard criteria. Wicking. Wicking is the flow into tightly restricted openings. Okay, this is, you have an advantage when you fix stone brakes because you're pushing it in under pressure. So with a stone brake, you have a closed surface and you have a piston cylinder when the piston is pushing the resin, and that's how it gets into those tightly. It's much easier to get into those restricted openings. It can be compromised by working in sunlight, because if you're working in sunlight, that resin, as soon as the UV hits it, will start to cross-link and thicken, and it won't wick. It won't get into those restricted places, and then you have a compromised repair. Cold glass. Okay, cold glass is more dense, so the molecule is harder for the molecules of the resin to bond to the molecules of the glass when it's cold. Okay, because, well, even people, they don't like to bond when they're cold either. They like to be warm. The viscosity, if it's too thick, it will not get into, not wick the glass either and get into those tight spaces. Viscosity will be changed again when you're working in sunlight, because you can start out with a 20 CPS resin. If you're working in sunlight, within a few seconds it can be up around 100, and then you could have a problem wicking. That's why you want to shade your repairs until you're ready to cure. Doing a repair too fast can also compromise wicking in a crack, especially in a crack. If you inject it too fast and hit it with sunlight too quick, it can compromise the wicking. Now, priming. Priming is a process that many windshield repair companies don't use. We sell many primers and adhesion promoters. And the reason is the glass on the inside of a stone brake and a crack, when it first breaks, it's pure. There's no contamination, and that surface is rough. If you saw it under a microscope, it looked like the Rocky Mountains. It's got peaks and valleys, and even though you can't see that with naked eye, that's what it looks like. The glass on the surface, okay, has many contaminants and surfactants on there. That's why sometimes when you go to pit fill and you are done curing and you grab your film tab and the resin comes off your film tab and didn't stick to the glass, okay? The reason it didn't stick to the glass surface was because there were surfactants on there, such as Rain-X or car wash or other hydrophobic coatings. They can go to a car wash and they can get a lot of stuff stuck on their windshield. But now the inside brake doesn't have those contaminants if it's not too old. If you have a really long crack that has opened up, it can have contaminants and surfactants in there. In that case, you have to use a primer. The primer is going to remove those surfactants off of the glass, and so that the resin can now bond and interact with the glass. And then primers, some of our primers actually even change the surface. You can actually change the surface so you can get a better adhesive bond to the glass. Okay, so again, it's very important to understand wetting and wicking, because what you're trying to do is get an interaction between the glass and the resin. And the other thing is to get a bond onto the PVB, which we're going to cover next. Shrinkage, okay? Windshield repair resins, or thin resins, low viscosity resins, shrink. The higher the viscosity, the less the shrinkage. Epoxy doesn't hardly shrink at all. Very, very little shrinkage with epoxy. The resins that we use in windshield repair are acrylic-based, UV-cured resins. They are also known as radical. They're a radical bond. A free radical bond is a double bond. It's a tight-knit structure. Okay, now what does that mean? Well, a double bond means the molecules are bonding on two ends. They're bonding to the glass, and then they're bonding cohesively to themselves. Okay, so let me give you an example of what that will look like. Let's say you are in a room full of people. The room is packed, people, all four corners, and everybody in the room has to join arms on both sides. Now you would see the people that took up this much space join arms, and then they'll take up that much space. Well, that's what happens when a resin shrinks, is those double bonds bonding on both sides causes the volume to shrink. Okay, exothermic. The UV cure is exothermic, meaning that it creates and releases heat, which also causes shrinkage. And then there's another thing called surface tension, which I was covering earlier, and this comes into play because, again, we have two substrates. We have glass and we have PVB. And these windshield repair resins wet the glass and not the PVB. So that means when you go to cure, it will pull back and off of the PVB. Now when you hit the resin with UV light, what's happening is those molecules in there are going to bond and link to the glass, and they're going to link to each other. Okay? So what happens is they're going to pull up and start cross-linking, and they're going to pull off of the PVB because, again, they have no chemical molecular bond to the PVB because the PVB is low energy. So you might see that, like if you fix a crack and you dump low viscosity resin in the crack, in a long crack, when you go to cure it, you can see this. So you can see the resin come off of the PVB, and you'll see a line of refraction. We call it a runner. It can be this big, but as you cure, you'll see this thing start growing and growing and growing. Okay, that's the surface tension of the resin pulling up and off the PVB because it is more attracted to the glass. Okay? And those molecules are what they're doing is they're bonding to the glass, and they're bonding to each other to form a polymer. So the monomers, the molecules, the monomers turn into polymers in the glass. What happens when you have shrinkage is it creates residual stress within the structure. Okay? Because instead of having a loose bond like this, you've got a tight bond like that. And it doesn't take much stress from like temperature change or from the insulation stress to start snapping those cross links. So how do you get rid of shrinkage? Okay, well, with a stone break, it's easy. You cure it under pressure, and with a crack, to deal with surface tension, you cure that by viscosity. Here's how you compensate for it. Rule of thumb in any adhesive application is to overfill. Overfill. How do you overfill a stone break? You leave it on pressure while you cure. Okay, that will compensate for the shrinkage. It will also force a mechanical bond onto the PVB. If you overfill that space in a stone break, it's going to stay on the PVB, and you have forced a mechanical bond onto the PVB. It'll stay clear for the life of the repair, years and years and years. If you pull your injector off, okay, the resin is going to shrink. You might not see this right when the repair is done, but you do not have a bond, a very good bond to the PVB, and the void, the space, has less resin in that than it did if you would leave it under pressure, because you'll have more resin in there, more cured resin, more structure. Okay, what will happen is down the road, when the glass gets cold and the PVB turns hard, it'll start to separate even more from the resin, and then down the road, especially in an ungaraged vehicle, your repair will look like it's not repaired. It can still be partially bonded to the glass, but it'll be off the PVB and it will look horrible. How can you check that? Well, go call up 10 of your customers that if you don't cure under pressure, call up 10 of your customers that you did that do not garage their car, and you're in a 4-season climate, and you'll see what the repairs look like when you don't cure under pressure. In a crack, the viscosity is what makes it stay in place on a crack. Okay, because there is no wetting of the PVB, the resin has to stay put when you cure it, and the higher the viscosity, the more mechanical the resin is, and that's when it will stay put and stay on the PVB. Prior to the process that I developed to fix crack, which was first called the multi-viscosity method, and then we had also had minimum viscosity methods. And a major portion of that those patents that I got were about keeping the resin on the PVB and holding the installation stress. A slow cure, okay. You know, you can go buy some pretty expensive cure lights, or you could buy some very inexpensive cure lights that do it slow, and you can buy expensive lights that do it fast. Well, you're better off buying less expensive curing lights and doing it slowly, because a slow cure controls shrinkage. Not as much stress. Too fast of a cure increases shrinkage and stress, okay? When it's going slowly, it's going to go like this and bond, and when you do it fast, it can go like that. What happens is not enough of the molecules get cross-linked. You have molecules that are just stranded, and not enough of the molecules will bond and become polymers. Okay, your monomers won't become polymers, so and you'll have a less of a strong or durable structure. Let's talk about drilling and tapping a bullseye. Now, why do you do this? A bullseye, you've all seen a bullseye in a windshield. It's a round-shaped break. In the old cars back in the 50s and 60s, when the glass was 1/4 of an inch thick, when the stone hit, they got bullseyes. I mean, it's big black circles. Okay, that's a cone-shaped break. And you don't see those very often now because the glass is only an eighth. The whole windshield now is 1/4 of an inch thick. Each one of the light, the outer light, the outer layer of glass is only an eighth of an inch thick, and the inner layer is under an eighth of an inch thick. And the reason they do that is to drop weight for gas mileage purposes. You know, the vehicle manufacturers are always pressuring windshield manufacturers to lower the weight of the windshield. Well, the way you do that is you make the glass thinner. But what has happened from making the glass thinner is windshields are now the #1 insurance claim in the United States. And my feeling upon that is windshield is not just a wind shield, it is a safety shield. So I don't think you should be cutting corners on a safety shield. What does this do? Well, when you have to drill, you drill halfway through the outer layer, and then you tap. And what this does is this makes a little bullseye. Now this comes in handy at the tip of a crack. Also comes handy on a leg of a star break that didn't fill, because it makes a bigger passage for you to get into that break. When you're doing it in front of a crack, what you've done is you've created a little hole where the crack can terminate into that hole. And once you fill that hole, that little bullseye up with resin, and you have terminated the tip of that crack in that bullseye, it'll never spread on you. It will not go anywhere. So what that does is that bullseye gives you a mechanical stop, and the resin gives you a chemical stop. So you have two things to stop the crack. If you ever fix a long crack and you don't do that, if you don't drill on top of the bullseye, all you're banking your repair on is a chemical bond. Okay, and the tip of the crack is very tight, and you didn't get a structural adhesive in there. You only got an adhesive in there. Re-repairs. Yes, they can be done. Most experts in this business, or if you know how to drill on top of bullseye, you can do re-repairs. Now, there is a big market for re-repairs these days. A lot of you who've been in the business for a while, you will notice that you see a lot of safe light repairs that don't look like they're repaired. And the one reason that occurs is, #1, their tool pulls up on the glass. When you pull up on the glass, you shrink the break and close the cracks. And so less resin gets in there. They also don't cure it under pressure. So they have less resin than you normally get in there. Then they don't cure it under pressure, which creates those problems I was just talking about of shrinkage and no bond to the PVB. Here's an example of one. This one came into our shop. Now you can see they didn't get resin into any of those legs. But what I did is I drilled and tapped the bullseye onto each one of those legs, and that was the result. You can see that's totally bonded. Drilled, tapped a bullseye, filled it up with about a 20 CPS resin, and cured it under pressure. Okay, so I took a mess of a repair and then did a re-repair. We also sell a re-repair resin. We sell a re-repair resin because you need a resin that's going to bond both to glass and the resin that's in there. Some resins don't bond to other resins. Now the other thing you need to understand with adhesives is the substrate, which is the windshield, or what I like to call the safety shield. The stresses in the glass. There's these stresses you're dealing with in the glass. Residual stress is in the glass. This is the weak spot around the perimeter of the windshield. It's about 2 inches wide, and this area of the glass, during the manufacturing process, when they bend the glass and it goes through the annealing process, the temperature changes in there from the cooling of the edge versus the middle causes the molecules to split, and it creates the weakest area of the windshield. It's called the weak spot, and it's 2 inches wide. That area of the windshield fractures 2.5 to 5 times easier than the rest of the windshield. If you fix cracks, so you're going to start fixing cracks, what you're going to notice on your edge cracks is over half of them, the impact point is going to be about the size of a grain of sand, a pinhead size. That's all it takes to cause an edge crack, is a surface chip. A surface chip the size of a pinhead in the weak spot will cause an edge crack. It does not even have to be a star or a bullseye or a combination break or a partial bullseye. All you need is a surface chip in the weak spot, which is on the frit area, and you will have an edge crack. And you'll see half of your edge cracks will have that impact point. Residual, that's the residual stress that's in the glass, and that occurs during manufacturing. It's a tension stress. Induced stress or installation stress. This is the stress around the perimeter from gluing it to the vehicle. That area is called the flang or the pinch weld that the windshield is sitting in. That stress is the urethane pulling the glass and bonding it to the vehicle. You can feel that stress. It goes out about 4 inches. If you go out to your windshield and take your knuckles and knock on the edge of your windshield, you'll feel how tight it is until you go out around 4 inches, and then it'll start feeling hollow. That induced stress causes an impact or a chip in the weak spot to crack immediately. And this is also what causes the crack to split open. When you fix edge cracks, as you're going to notice, there's a wide gap at the edge and then it starts to close. That's because the installation stress has pulled it apart, pulled the glass apart, and then it will close when this stress pulls it back together. Now the frit is the black ceramic paint that's on the inside layer of the windshield. This is a defect in the glass. Whoever designed this, any engineer that designed this has actually contributed to making windshields the #1 insurance claim in the United States. The frit is baked on into the glass when it goes into the furnace. And putting the frit on weakens that area by 40%. So you have already weakened that area by putting the frit on, and then you throw the residual stress on there from the annealing process, and you got a mess at the edge of the windshield, the first few inches, and then where the frit is. That's why you're going to notice most of your cracks have an impact in the frit. Now lamination stress is your friend, and this is the bond of the PVB to the glass. This bond is about 3,000 psi. The lamination stress is why stone brakes don't crack. Stone brakes, star brakes, you'll know, they can sit in a windshield for years and never crack. They only crack from temperatures. Severe temperature change, severe cold, or severe heat. What's holding them together is that lamination PVB bond to the glass. This is also what stops a crack. When you get an edge crack, when a chip occurs in the weak spot and it cracks out, that insulation stress pulls it apart, and then the lamination PVB bond pulls it back together. And it stops when this stress becomes greater than that stress. Okay? That usually stops the crack. It's usually around 8-10 inches. Okay? That's why that lamination stress is also why you can pry the crack open to get your resin in on an edge crack or a floater crack, and it doesn't spread on you unless you push too hard. Okay? But that's your friend. The lamination stress is giving you, on a repair, it's helping you out by 3,000 psi. So your repairs already have a 3,000 psi help or bond from the lamination holding things together. That weak spot in the glass that I was talking about on the edge. This is what it looks like on a polariscope. This is what it looks like before it's installed. And then when you install it, you're installing it on the weakest part of the windshield. It expands it and intensifies the weak spot and makes it even worse and larger. SAE, Society of Automotive Engineers. We did some testing of windshields back in 2002. And believe it or not, you can't find too much testing done on windshields. And this was a fracture test. So we were doing a test just to confirm that the edge of the windshield fractures easier than the middle. It was done by Knott Lab, and the Society of Automotive Engineers published this report. You can buy this report, that's the report number, for about $10, $11 on the Society of Automotive Engineers website. But here's what was on here. This was the force to fracture the edge area, and we had, see, 1, 2, 3, 4, 5, we had 6 windshields, 2 of them are the same. And this was the force to fracture the edge, and the FYG, the Safely, the Chrysler Safeguard, their OE, that was the factory one, and that was their aftermarket one, which is one and the same actually, because they don't have aftermarket of that brand, and Pilkington and PPG. Now this was one windshield. This is not real accurate because it was, if you were to really test this, you'd have to test like, anywhere from 3, 4, maybe even 10 of them to get more accurate data. But the point that we were trying to prove is that overall, all these windshields fracture easier on the edge. We also have a product called Edge Guard. Edge Guard is a coating that goes over that weak spot to prevent edge cracks. And this shows you what the Edge Guard improved that weak spot to. This is how much harder it was to fracture in the edge area weak spot when we coated it with one of our many Edge Guard coatings. You can see more about our Edge Guard at edgeguard.com, and on our Ultrabond website there is a section in our online store called Edge Guard, and that's a spray-on coating that we put on the perimeter of windshields over that weak spot before we replace them. And this is the force to break the center. And as you can see, the force was higher on most of these windshields to break the center. Some windshields like this one was terrible, both on the middle and on the edge. And then once we coated them with our Edge Guard, some of them you couldn't even break them. Now let's talk about how these stresses on the windshield, the lamination and the induced stress and the weak spot, relate to your repairable damage. What are you going to repair out there? Well, this was about 10 years ago. Our total repairs over a year period or 2-year period was 3,000. 1,296 of them were stone breaks, and 1,142 were cracks, long cracks. So what I'm showing you here, though, if you are in the repair business and all you're fixing is stone breaks, you're losing out on more than half your income, because your average stone break is going to be $50, $60, and your cracks go for $100 to $150. So if you're just fixing chips, you should look into fixing cracks, because you're going to more than double your income. Also, fixing cracks, if you don't do replacements, it puts you in the repair versus replacement market, and you're less expensive than a replacement. So this is the type of damage that you'll see out there if you can fix everything like an Ultrabond technician can. Here's some data on the crack repairs, edge cracks and floater cracks. The edge crack represents, this one was recent, 2014. Our data showed edge cracks were 95% of the cracks that we repaired. And the floater crack, which is a stone break that cracks out, were only 5%. Remember, I told you a stone break has that PVB bond, the 3,000 PSI bond holding it together. So they don't crack out that often. Whereas the edge crack, when that fractures, it cracks immediately. See, when a stone hits a windshield, it does one of two things. It causes an edge crack if it hits the weak spot area, or it causes a stone break if it hits in the middle. Well, 95% of repaired edge cracks were over 6 inches. Why is that? That's because of that induced/insulation stress. That stress causes an edge crack to go over 6 inches 95% of the time. In fact, 95% of all repaired cracks, this is floaters and edge cracks, were over 6 inches long. Now, you might hear insurance companies and third-party administrators and windshield manufacturers telling consumers you can't fix it if it's longer than a dollar bill, which happens to be 6 inches. Well, that's called deceptive trade practices. They're deceiving the consumer and telling them that something that is repairable is not. And if you're doing that, if you're a replacement shop and you're doing that, then the consumer goes to the Repairable Laminate Auto Glass standard and finds out that the standard says you can fix these things. They actually could sue you for deceptive trade practices. It's just like if you had something wrong with your car and the option was, well, I can repair it for you for $90, or I can replace it for you for $355. That's the option you want. If you think about it, when you want to have something fixed, you want to know your options and you want to know the truth. Can it be repaired and how much is it? Or do I have to replace it and how much is that? Okay, well, when you tell the consumer you can't fix it because it's longer than 6 inches, you just lied to the consumer. And that can hurt you down the road if the consumer finds out that you lied to them. They'll never come to you again. And another thing, think about yourself. If you need to have something fixed, do you want to be lied to? And do you want to be deceived? Or do you want to know the truth? And the truth is, cracks, where the standard says 14 inches. Okay? 14 inches and under is repairable. That's what the Repair of Laminated Auto Glass standard says, and that is the windshield repair standard in the United States. And believe it or not, we fix them any length because we want to collect data. And what we have found is 84% of repairable cracks are in the Rolex standard 14 inches and under. 84%. The correlation is the longer the crack has been there, the more chance it has to become contaminated, and that is the only enemy to whether you can repair a long crack or not. Now, like I was talking about the insulation stress opening up the crack. Well, normally cracks under 14 inches haven't opened up wide enough to allow a lot of contaminant into it. Whereas once they get 2 foot long, 80% of them are contaminated, and even if you try to get the resin in there, they'll be full of dust. Here's another thing you're going to find if you fix cracks, or if you examine them when you replace them. 82% of edge crack impacts are in the frit area. That's 8 out of 10 will have an impact in the frit. Now, earlier when I said the frit was a defect, well, I got to ask yourself if you're an engineer, because even a layperson knows that when glass gets hot, it is less dense and it fractures easier. So here's the weak spot in the windshield, and you got black paint in there generating heat, which is going to expand the glass, make it less dense, and cause it to fracture even easier. Okay. In fact, that frit is also one of the reasons why windshields are the #1 insurance claim in the United States. Specifically, the edge crack. The edge crack is actually the #1 insurance claim in the United States, and a frit plays a big part in that. So actually, the frit's your best friend because the frit's out there cracking windshields. The ratio of stone breaks to floater cracks. Okay, like I saw, floater crack. You'll like the fact that you don't see these very often because they're harder to fix than the edge crack. But our data showed only 2% of the actual stone breaks we fixed were actually turned into floater cracks. Now these are parking lot surveys that were done in the 1990s, and there were about 14 different cities, over 5,000 some vehicles. But these numbers were almost identical to the data from the repair shop, in that the number of stone breaks versus floater cracks was about the same. You can see there was over 2,400 stone breaks and 121 of them had cracked out. Number of edge cracks was over 10%. We had miscellaneous damages like vandalism or golf balls hitting windshields. But the reason we did these surveys is we wanted to see if what we saw in our shop was relevant to what was actually out there in the real world. And the most logical place to study windshields to see if what you're seeing in your business and your business data is the same as in a parking lot. What the parking lot findings found is that 84% of cracks were edge cracks. And we saw in 2014, 95% of our cracks were edge cracks. 16% of cracks were floater cracks. This is back in the 1990s. Now it's 5% are floater cracks. 11% of the vehicles were edge cracked. That was, again, this was in the 1990s. Might have even been 2000. But 1 out of 10 vehicles have an edge crack. And the ratio of stone break to floater crack was 6% back then. Now it's about 2%. Or was it? Yeah, it was 2%, I think, yeah. That's the ratio of stone breaks to floater cracks. But anyway, the parking lot findings and the data from the shops, they're pretty close to what they do. And I think that's it. Okay, that is the end of this PowerPoint presentation. Again, I hope we gave you some data that you can use in your business, and I hope you understand the stresses on the windshield and adhesive properties so that you know how to do it right. Again, my name is Richard Campfield. I'm from Ultrabond. You can go to our website at www.ultrabond.com. We have a lot of information on our website. If you go to the bottom of our web page, there's a lot of information of links in the bottom of the page. There's a free manual on there on fixing stone breaks. You can get a lot of this information again. And if you have any questions on anything that you saw in here, or you didn't understand, or you want to talk to me, feel free to call me. You can go to my website, get the phone number, and give me a call, or send me an email. And thank you for watching.